By rights, the night sky should be brighter than the surface of the sun. A seamless wall of fire in every direction. Go on, go and look. It isn't. And that tiny disappointment is hiding the age of the universe. Welcome to Splendidly Silly Science, where it's dark outside is treated as a catastrophic mathematical error. Here's the logic that breaks everything. If the universe is infinite and eternal and stuffed with stars, then every single line you trace outward forever has to eventually smack into one. Picture standing in an endless forest. Look dead level, any direction. Sooner or later, a tree trunk. No gaps anywhere. Now swap every tree for a star. The whole sky should be solid, blinding light. So, the cosmos should be one uninterrupted blaze, hotter than any beach holiday you have ever regretted. Instead, you get that. Mostly black. A few specks. Bit awkward. This is Olbers Paradox, and "the sky is dark" sounds like the dullest sentence ever spoken, right up until you realize the darkness is screaming something at you. And before you say, well, space is mostly empty, it isn't. Aim a serious telescope at the blackest, most boring scrap of sky and just leave the shutter open. Thousands of galaxies bloom out of the dark, each one billions of stars. And yet, that little patch is still overwhelmingly empty. Black. The paradox just gets worse the harder you look. Between any two stars sits an absurd gulf of almost perfect nothing. Light years of vacuum where one photon can travel for an eternity and hit precisely nothing. That nothing is most of everything. Except in a universe with infinite depth, the gaps don't save you. Look far enough through any gap and a more distant star should plug it. Stack enough distance and every gap fills. So why hasn't it? People have squinted at this for centuries. The maths refused to behave long before anyone could explain why. One particular astronomer got his name welded to the problem, which is the science equivalent of getting blamed for the weather. The tidy fix was this. Maybe great clouds of dust and gas float out there, quietly soaking up all that distant starlight before it ever reaches us. Lovely idea. Completely, gloriously wrong. Soak up that much light forever, and the dust heats up. Keep going, and it glows just as fiercely as the stars it was meant to be hiding. You cannot hide a bonfire by wrapping it in more bonfire. Others wriggled out a different way. Maybe stars clump into groups, and groups into bigger groups, thinning out with distance so the sky never quite fills. Clever. Buys you a little. Doesn't get you off the hook. My own graphics department keeps trying to render the wall of fire, and the universe keeps reaching over and switching the lights off. Honestly, relatable. The first genuinely good answer didn't come from an astronomer at all. It came from Edgar Allan Poe. 1848, the Raven Man, in a sprawling prose poem, quietly sketched the thing the professionals had all walked past. His idea: perhaps the far stars are simply so distant that their light hasn't arrived yet. The universe might just be too young for the whole picture to have finished loading. And that's very nearly it. The universe is about 13.8 billion years old. Light is quick, but it is not instant. So we only ever see a finite bubble. And a finite bubble holds only so many stars. Trace a line between the specks and, more often than not, it sails clean past every star within reach and out into the dark. The forest has an edge, after all. We're just standing very, very near the door. Here's the bit the documentaries skim past. Even given a vast universe, stars haven't burned long enough, and there simply isn't enough starlight in all of existence to wallpaper every line of sight. So, the headline answer is time and fuel. The universe is too young, its stars too few and too short-lived to fill the sky. The stretching of light matters too, but it's the supporting act, not the lead. Because space itself is expanding, stretching light while it's still in flight. The most distant glow gets dragged right out of visible color, down into infrared. Your eyes were simply never built to catch. Think of it as a party that only just kicked off. The guests from the nearby rooms have arrived. Those are your visible stars. The ones from the far wings are still walking over, and some are strolling so slowly their footsteps have dropped below anything you could hear. Now the part that should genuinely unsettle you. Point a microwave dish at the blackest, emptiest patch of sky there is, and it glows, evenly in every single direction at once. That glow is the leftover heat of the early universe, from back when the whole thing was a blinding, opaque fireball. Olbers' wall of fire is real. It was always there. It's just been stretched by 13-odd billion years of expansion, cooled from a furnace down to about minus 270 degrees. The fire didn't go out. It went quiet. So the night isn't empty. It's a wall of ancient fire, red-shifted so far past your eyes that it simply reads as black. You're staring at the brightest thing in existence and seeing nothing. Sit with that. The blackness overhead isn't the absence of an answer. It is the answer. A sky this dark is only possible in a universe that switched on relatively recently and has been thinning out ever since. Which means the darkness is evidence. A truly infinite, eternal universe really would cook you alive. The only reason you aren't blinded right now is that the universe had a beginning and isn't very old. And it is getting worse. As the expansion speeds up, it'll drag the other galaxies out of view, one by one, red-shifting each into that same silence. The sky is slowly going out. If you'd rather not sit in the dark waiting for the lights to finish going out, keep this terminal latched onto the early signal. We run a standing tally of the oldest photons still limping in from the edge of everything. Or just step outside and stare into the gap yourself. Your call. Here's the one to lie awake on. In the far future, Expansion will have hauled every other galaxy out of sight. The astronomers alive then will look up, see one lonely island of stars, and conclude the universe is small, static, and eternal. And they will be completely, confidently wrong, with no possible way to know it. So how much of our own physics is just the part that hasn't redshifted away yet?